Hi, it's Rich Tehrani here from CTIA 2010. Thanks for watching. Today we're going to be speaking with Eitan Schwartz, who is with RAD Data, and he is the VP of pseudowire and Ethernet access. Eitan, how are you?
Very well. How are you, Rich?
I'm doing great. Thanks for being on the program today. Tell us a little bit about what's new.
Well, RAD has been focused in the last few years, especially in carrier Ethernet. And we've actually combined a few areas to provide solutions for the mobile backhaul space. Already in the 1990s, we had a good mobile backhaul solution, a lot of ATM type products. And we then, in the late 1990s, invented a technology called TDM over IP, which allowed you to emulate TDM traffic, T1s and E1s, over IP. And that became later pseudowire. So what we've actually done is we've combined various technologies. We combined pseudowire, carrier Ethernet, and accurate timing capabilities, and created a portfolio of products for the mobile operators and also for the access providers, the wholesalers that deliver services to the mobile operators. In general, RAD focuses on the access side of the network, which is, and we have about 250 products. So we have all the different technologies to allow you to run over any kind of access network: fiber, microwave, DSL, T1, Sonnet, etc. And then to provide all the Ethernet and TDM and ATM type capabilities for mobile backhaul. Recently, the main focus has been performance monitoring, where these devices allow the mobile operator to test from his switching center to the cell site and confirm that all of the performance of his connections is suitable for the cell site and there's no degradation with time, and that he can accept the circuit, that the bandwidth is good, and so on and so forth. But then also timing has become very important.
Sure.
Because in each case, the mobile operator requires an accurate clock reference to ensure that he doesn't have dropped calls as he hands off traffic from one connection to another. So just in this last year, in 2009, we had success, for example, in Europe with seven backhaul applications, where we were also the first vendor now to actually have an integrated solution that provides timing based on SYNCI and 1588. So it actually allows the mobile...
two standards right now, the two competing standards, right?
They could be competing, but they're typically complementary. What happens is 1588 is a standard that allows you to extend timing across a packet network. So it doesn't have to be supported by each of the devices along the way. Whereas synchronous Ethernet is a layer 1 synchronization method, pretty similar to TDM Sonnet type synchronization. It's great for frequency reference. The problem is that every element along the way has to support it. So what we've done actually inside our cell site demarcation devices is we've allowed you to actually convert from one timing to another. So if, for example, timing comes in across the packet network, either with 1588 or with adaptive clock recovery,
right,
we could then hand it off to the base station,
right,
either on a BNC or an RJ45 or a DB9 or an Ethernet, a SYNCI. So
right,
we can do conversion of any timing protocol to any other timing protocol. We can also accept timing from a GPS source and so on. So that helps the mobile operator, because now he can use a single demarcation device for performance monitoring, for circuit validation, but also for timing.
Right.
You know, typically he'd require either GPS or he'd require a separate timing device.
Right.
So it's all integrated, fewer boxes, higher reliability, and so on. The other strong area for RAD is that we do very well in the wholesale environment.
Right.
So that's the wholesale providers that may be going out to the cell tower, they're investing a lot of money building out fiber facilities, and they want to be able to support multiple mobile operators. So we allow them to do, for example, multiple timing domains. So they could give, if they've got two mobile operators, they can give them each timing from their own switching centers without dependence. So
right,
one mobile operator isn't dependent on the second one
sure,
losing connection for his traffic. So that's the one thing. And then we can also do integrated pseudowire. So where you have multi-generational backhaul, 2G, 3G, 4G, you may need T1s or E1s for the 2G, 3G traffic,
right,
and then maybe Ethernet for the 3G, 4G traffic. So from the same device, they could provide all those different types of traffic, but also provide performance monitoring. The wholesale is needed as well as the mobile operators.
Sure.
The wholesale is actually needed to defend their SLAs and also to identify any degradation in their own network.
So what's the biggest challenge that the backhaul market is facing right now?
Well, extending facilities out to the cell towers. The mobile operators are looking for scalable Ethernet bandwidth, and they're not necessarily able to pay a lot for it. So it's, can you build out the facilities all the way to the tower and just sell Ethernet?
Now, when you say they're not necessarily able, is that because they have fixed rate data plans, or what is the reason for that?
Well, the amount that they get back per bit that they sell at the moment, so the traffic is growing by a much faster rate than the revenue that they're getting. So it is that fixed plan where perhaps you've got a 20 times increase in bandwidth per user, but only a very small incremental increase in revenue per user.
And with these new devices that are coming out, especially tablets, competing tablets, we're going to see a number of them in the next few months from Apple, and obviously Android-powered tablets. There's one on the market, maybe there's a few on the market, and we'll probably see dozens. I can imagine that the data explosion in the next 5 years could be even worse by an order of magnitude than the last 5 years.
Absolutely. And
orders of magnitude.
That's absolutely correct. And actually that leads you to another area that is very important for the mobile operators, and that is efficiently using their bandwidth, because they're going to be competing, and there's going to be a lot of best effort type traffic that they can't necessarily carry at all. But they can't let critical control and signaling traffic, for example, get dropped. So it's very important that at the cell sites, they are able to traffic engineer, they are able to correctly prioritize the traffic, identify different traffic sources from different base stations and different priorities within that, and then ensure that the highest priority traffic gets through. So there could also be a scenario where the mobile operator maybe aggregates traffic from a few cell towers, and then he buys a pipe from, say, a wholesale provider, and he needs to make maximum use of that pipe. And I think long term, as you were saying, there's more and more smartphones and the iPad and so on that are going to be demanding a lot more bandwidth. I think people will be looking at coverage, but also performance, and there'll probably be reports on performance of one mobile operator compared to another, and you'll make some of your decisions based on their backhaul. So they have to actually build out those facilities. It's a bit of a chicken and an egg scenario there.
That's great. Well, Eitan, this was fantastic. I really appreciate your time on the program. Hopefully we'll see you again at future events, and good luck on everything you're doing.
Terrific. Thanks, Rich.